Yeah, we can proceed now. I will share my screen. I get that. Phone in the phone. Yeah. We already discussed about what is embedded systems and what is automotive embedded systems and what is the automotive embedded testing. We already discussed about this thing. And we discussed about what are the types of jobs will be available in the automotive embedded systems. What type of course we are defined and how it will be useful in automotive embedded testing, right? That thing also we yesterday discussed. We are mostly our course will be related to automotive embedded software test engineer and test automation engineer, and also one more role, the configuration development team. Okay, these three roles will be applicable for this course. Like if you need to enter into the automotive embedded, like a embedded software test engineer, here we can wrote the manual test cases and execute the manual testing processes. That thing we will cover it in our course. And next coming to automation engineer, test automation engineer. Here we are teaching us by using Capel script how we need to run the automated vehicles, automated test cases. Those are we are teaching here. Okay. And coming to that configuration development team. What is this configuration development team? What type of work will be available in that? Here, what you need to do, we are developing the panels for the manual testing purposes. In the configuration development team, they are developed one configuration file. That file will be which is related relevant to Canoe tool. In that configuration, all the panels um, panels which is presented with the Capel code. We have the database. We will teach you how to create the database also. But in real time, we are not getting that. We are not need to create the database. We will get the database from the client side, from the client. What are the requirements they needed? What are the types of messages they needed? What are the types of signals they needed? They will send from the client. Those things, according to that database, we need to create the manual test bench manual setup. That manual setup which is relevant to with panels. The panels we need to create the environment variables. So those and all will be available. Panels, system environment variables. Those and all. Okay, that's thing how we need to create the panel. How we need to create the wrote the Capel script for those panel. How the panel functionality will be work and how to create the database. These things will teach us in our course. Okay, that is relevant to configuration development. After completion of configuration development, their send the configuration file to test engineer, the software test engineer. He will test the hardware with respect to those panels. Then it is as a manual testing or automation testing, both. Okay, and coming to these are all completed at yesterday. Yeah. Next, coming to we already defined the nodes, the ECUs. ECUs will be communicated with respect to CAN protocol. With respect to CAN protocol. Okay, this CAN means controller area network. Controller area network. Okay. And protocol means set of rules. It's rules. Protocol means rules. Okay, these rules, according to this CAN protocol, will be accepted. These are the rules. We have a lot of rules for the CAN protocol also. It will be accepted. Then the communication will be gone into the successful state. Otherwise, it will be in failure state. Okay. We'll tell you later the rules. Okay, the controller area network. What is the why what is the communication main thing? What is the communication? We need like for an example, I am the Rahul. I'm communicating with you with respect to Zoom meeting. With respect to Zoom meeting, I'm communicating. We are using one device. The device is the application. Application is called Zoom. Right? You are connected each other from the Zoom, right? Everybody will be connected through the Zoom. I'm communicating with respect to Zoom. You and remaining candidates are communicating with respect to Zoom one. If I like in the Zoom meeting, in the chat box, we have one option that is everyone. If I I will message, I will ping you, hi. It will be reaches to each and every candidate in the Zoom meeting. This chat box, it is also called as one communication for us, right? Like that, in the embedded systems, we are using one communication device. The device is called as a controller area network. This controller area network has set of rules. Okay, and how it will be communicate with respect to nodes? How it will be communicate with respect to nodes? This is the device. Like this is the device. This is our network node. This is our node, microcontroller or our device. This is our device. Our device will be connected through the one setup, that is the CAN controller. The CAN controller to CAN transceiver. We will define why this one using, why this one using. One second. Yeah, sorry. Okay. Our each node will be connected through these two wires. These are the two wires. This one is CAN low and this one is CAN high. These two wires are connected with these two resistors. These two resistors are 120 ohms of resistors. 120 ohms of resistors. Okay. Why we are connected 120 ohms of resistor and why the communication will be happen like this. I will tell you in the next classes. We have a lot of stuff. Okay, just I'm introducing what is the CAN protocol. And the CAN protocol is a communication protocol used primarily in the automotive industry for enabling communication. It is used for communication between the various electronic control units. Various electronic control units. That is called as an ECUs. In the classes, we can define as a nodes. Nodes. That's it. Nodes with a vehicle. It was developed by Robert Bosch. It will be developed by Robert Bosch in 1980s to address the need for reliable and efficient communication. It is why it is used for the efficient communication, the efficient communication between different vehicles. Okay, before the CAN protocol, we doesn't have the before the CAN protocol. It will be developed by after 1980. Before 1980, the vehicle system will be connected through like this is my node 1 and node 2 and 3. This one has a 4 and this one has a 5 example. We can take as like each node like here to here, here to here, here to here, here to here, a communication like here to here, like okay, like this, each and every node will be connected, and each and every LED, each and every sensor, you need to connect manually. If you like, if you break something, if you get something break, this node will be connected, it's not working properly, then it might be failure. It may be failure the whole device. It might be failure the whole device because like the communication will be going IO to here and here. The communications are going on. But after that, you get the communication from these nodes also. Here onwards. Like each and every node will be connected through like this. The communication will going to here. The communication will be coming from here. Like it will be connected with whole system will be connected to the wiring systems. If you break any wire here between us, the communication will be problem for whole the system. Whole the system. That's why they invented in the 1980 they invented CAN protocol. By using this CAN protocol, we can connect the CAN setup. We can connect the CAN setup. For an example, this is my CAN setup, right? This is my CAN setup. This node will be connected to directly to the CAN. This node also directly connected to this one, and this one. Every node will be connected to the directly to the CAN protocol. Right? This CAN protocol will communicate with respect to these ECUs as a transmitter, as a receiver. For an example, in my point of view, this is the transmitter, right? This is the receiver. You see, this is the receiver, right? Then it will be communicate. It will be there like what is the message there? It will be sending to the CAN protocol. The CAN protocol will communicate with respect to this ECU without a deflection, without a problem. You will be send the exact message to this node, and we after the completion of this node will be send the acknowledgement to CAN protocol. This CAN protocol, the message I got the message successfully. Like that, it will be send the acknowledgement to the CAN protocol. Okay, this thing will be happen with the CAN protocol only. If you get any problem, like if you get any problem, this node, we can break it. Remaining communication will work properly. Remaining communication will work properly. Nothing will problem for another devices. Nothing will problem. It will communicate with proper communication. Okay. CAN is designed to provide CAN is designed to provide robust and efficient means of transmitting data between various devices while minimizing the amount of wiring system. Why we are using mostly? It will reduce the wiring systems and it will share the efficient communication between the different vehicles. That's the two things. That the two things will happen between the CAN protocol. Okay. It employs two-wire bus architecture. Two-wire bus architecture. That architecture can high wire and can low wire. That's why it's called as an wire logic. Wire and logic. How the wire and logic will work, I will tell you at the next class. Okay, wire and logic, how it will be work, I will tell you that thing. Okay, this is the basic thing of the CAN protocol. And next we can move on into the properties of CAN protocol next classes. Okay, have you understand? If you understand, just please raise your hand. If you have any queries related to jobs or course details, is there any queries? We can discuss those things. And also we will provide like we will provide the CAPL code. Like this is our communication, right? We can take it as an example. We are authorized today. Like this is our output panel. We are developer here. This is our input panel. Okay, when we are we'll teach you these and all the stuff here. For example, now this stuff will be that click on the run mode. Like we are activating, we are teaching, and they are practicing each and everything. Okay, this is the trace window, how the communication will be happen. We can check out here. What is the channel we are using for the CAN protocol? How the database will be available. This is our database, one of the database we are developed for today. Okay. We will provide this Canoe tool to you also. Tool and our project also we can provide it. How to develop the project also we will teach you. How to write the CAPL code and how to write the test cases, those and all we will teach you in with real-time access, right? Okay, we can like that. After that, you doesn't have any doubts, right? If you have any doubts, just unmute yourself and ask the question. I will explain you that concept and all. I'm audible, right? Like audible. Hi.
అసలు ఎవరు మాట్లాడట్లేదు.
Sorry. Sorry, Madhavi, I didn't hear you. Can you speak once?
Sorry, it's by mistake.
Oh, yeah, my voice will be audible, right?
Yes,
I'm
yes.
confused because of nobody will be respond. That's why.
Yes, you are audible.
Okay. Is there any doubts? Do you have any doubts?
No. Actually, I didn't attend before classes, so
Okay.
I'm in the middle.
Okay. In the before classes, we are tell us what is embedded systems, and next thing, what is automotive embedded testing? What is the process? How we need to test the embedded systems? Those and all we are done it. After that, we have moved on into the what are the types of jobs will be available in the automotive domain, mostly for the testing roles. I'm not mentioning the developing roles, those and all. Just I mentioned testing roles.
Okay.
In the testing roles, one thing will be manual testing, another will be automation testing. We'll teach us both roles here. Automation by using CAPL script. If you need to work on with the automation in future or not, then it might be very helpful to you, this course also.
Okay.
Yeah. Today I'm little late because of we are different call.
Okay. It's okay. You said two buses, na, that one, what's
If
can,
you're comfortable with Telugu, right? We can know. So it's
can, without can కి డిఫరెన్సెస్ చెప్పారు కదా.
yes, yes.
అది కమ్యూనికేషన్ అనేది 1, 2, 3 అనేది ఇదివరకు ఇలా కమ్యూనికేట్ అయ్యేది. అంటే ఇన్పుట్ అవుట్పుట్ ఇంటర్ఫేస్ అనేది డిస్కనెక్ట్ అయితే మొత్తం అంతా డిసేబుల్ అయిపోతుంది అన్నట్టుగా.
జస్ట్ ఓకే. నేను ఇన్పుట్ అవుట్పుట్ అనేసి మెన్షన్ చేయలేదు. జస్ట్ మెన్షన్ యాజ్ అన్ వన్ నోడ్, అది ఇన్పుట్ అవుట్పుట్ అనేది ఒక నోడ్ గా తీసుకున్నాను. ఇక్కడ ఏంటంటే ఏదైతే మనం నోడ్స్ ఉన్నాయి కదా, మిగతా నోడ్స్, నాట్ ఓన్లీ ఇన్పుట్ అవుట్పుట్, రిమైనింగ్ నోడ్స్, ఏ నోడ్ అయినా కూడా మనం కమ్యూనికేట్ చేసేటప్పుడు, మన కమ్యూనికేషన్ చేసేటప్పుడు మనకి ఇంట్లో హౌస్ వైరింగ్ తెలుసు కదా. ఎగ్జాంపుల్ చెప్తాను. ఇంట్లో హౌస్ వైరింగ్ ఉంది కదా, మీరు ఎవ్రీ స్విచ్ కి, ఈచ్ అండ్ ఎవ్రీ స్విచ్ కి ఒక వైర్ ని కనెక్ట్ చేస్తాం.
ఓకే.
ఎందుకు హౌస్ వైరింగ్ చూసారంటే, ఓపెన్ చేశారంటే ఎనీ స్విచ్ బోర్డ్, దానిలో మల్టిపుల్ వైర్స్ ఉంటాయి.
లైక్ ప్యారలల్ కనెక్షన్.
ఇఫ్ ఇన్ కేస్ ఏదైనా బ్రేక్ చేశారనుకోండి, షార్ట్ సర్క్యూట్ అవ్వడం, లేదంటే కొలాప్స్ అవ్వడం, పని చేయకుండా పోవడం, ఇట్ విల్ బి హ్యాపెన్. బట్ ఇక్కడ ఏంటంటే క్యాన్ ప్రోటోకాల్లో, క్యాన్ అది అంతకు ముందు వితౌట్ క్యాన్ అనేది అంతకు ముందు ఒక హౌస్ వైరింగ్ సిస్టమ్స్ లాగా. అంటే ప్రతి సెన్సార్ కి, ప్రతి నోడ్ కి వైర్, ఒక ఇన్పుట్ రావడానికి ఒక వైర్, అవుట్పుట్ పోవడానికి ఒక వైర్. ఓకే, అలా ఎక్కువ వైర్స్ ని కనెక్ట్ చేస్తున్నాయి. ఇఫ్ ఇన్ కేస్ ఏదైనా షార్ట్ సర్క్యూట్ అయినా, ఏదైనా వైర్ తెగిపోయినా మొత్తం సిస్టమ్ అంతా కొలాప్స్ అయ్యేది.
ఓకే. లైక్ అంటే ప్యారలల్ సిరీస్ కనెక్షన్ ఉంటుంది అలానా? లేదంటే
లేదు. ప్యారలల్ అండ్ సిరీస్ కనెక్షన్స్ అనేది అది డిఫరెంట్. వైరింగ్ సిస్టమ్ అనేది, అంటే మీరు చెప్పేది ప్యారలల్ రెసిస్టర్స్ అండ్ సీరియల్ రెసిస్టర్స్, రైట్?
అంటే ఒకటి కట్ అయితే మిగిలిన వానికి పవర్ వెళ్ళకపోవడం అలానా? లేదంటే కమ్యూనికేషన్ అనేది డిస్టర్బ్ అవ్వడం మీరు చెప్పేది?
కమ్యూనికేషన్ అనేది డిస్టర్బ్ అవ్వడం. కమ్యూనికేషన్ అనేది డిస్టర్బ్ అవ్వడం మెయిన్లీ.
ఓకే. ఈ క్యాన్ ప్రోటోకాల్ వల్ల
అలాంటి కమ్యూనికేషన్
బైడైరెక్షనల్
డిస్టర్బెన్సెస్
ఉంటుంది.
ఉండవు. ఇఫ్ ఇన్ కేస్ ఏదైనా బ్రేక్ అయినా కూడా ఆ నోడ్ వరకే వర్క్ అవ్వకుండా వెళ్తుంది. అంటే ఆ నోడ్ కమ్యూనికేషన్ వరకే డిస్కనెక్ట్ అవుతుంది. హోల్ సిస్టమ్ కమ్యూనికేషన్ అనేది డిస్కనెక్ట్ అవ్వదు.
ఓకే. స్మూత్ వర్క్ అవుతుంది.
Yeah.
అండ్ క్యాన్ ప్రోటోకాల్ హై ఒకటి, లో ఒకటి అన్నారు కదా. అవి దేనికి అది అర్థం కాలేదు.
ఓకే. నేను ఒకసారిగా డిఫరెన్షియేట్ చేస్తాను. మామూలుగా అయితే మళ్ళీ మేము రిపీట్ చేస్తాం ఈ సెక్షన్. జస్ట్ మనకి 5 volts ఆఫ్ పవర్ అనేది, వీఆర్ ట్రాన్స్ఫరింగ్ 5 volts ఆఫ్ పవర్ ఇంటూ ది కన్వర్టర్. 5 volts. ఓకే. In the 5 volts, we have 2 wires in the CAN protocol. Mana each setup will be communicated with that 2 wires. One wire will be related to CAN high, another wire will be related to CAN low. Okay. If in case the 5 volts of power, right, we are transferring 3.5 volts of power with respect to CAN high. With respect to CAN high. Then remaining 1.5 volts of power will be transferred with respect to CAN low. With respect to CAN, then it forms as a dominant bit. That is called as a zero. Like if binary system, you know that, right? Binary systems.
Yes.
1, 0, like that. If you in the laptop also, it will be take like binary systems only. If you are providing any inputs, it will be analyzed with respect to 0, 1 only. Here also, if you are transferring any message into the CAN protocol, it will be identified with respect to 2 wires. The 2 wires, CAN high and CAN low. Okay, if you are transferring one, for example, you need to switch on the LED value will be 1 for on. 0 for off. Okay, then that period of time, how it will be transferred? If you need to transfer the LED, need to switch on the power, then it will be can high and can low wire will be transferred 2.5 and 2.5. Same power consumption, same power will be transferred into the CAN product. Then the CAN will be think on like I need to switch on the LED because of its transferring recessive bit. Recessive bit means 1. Recessive bit means 1. Dominant bit means 0. It will be think on like that. It will be think on like that. I'm clicking the on switch here. On switch here. On switch. Click on switch, but the message will be identified with respect to 2.5, 2.5. Then it will be form recessive bit as in 1. Then LED will be go on to the on state. If I click on the off switch, off, then it will be think on like can high value will be 3.5 and can low value will be think on it 3.5. This is called as a wire and logic. Every interviewer will be asked like why the CAN protocol called as a wire and logic. You need to explain this concept. If I need to transfer, I need to switch on the LED. Then that period of time, the two wires will go into the recessive bit. It will be formed recessive bit. How it will be formed? The CAN low value and CAN high value equal to 2.5. Then it will be formed as a recessive bit. Recessive bit means 1. 1 means LED on. Okay. If I need to transfer the dominant bit, I need to switch off the LED. Then the CAN high value will be reaches to the 3.5 and CAN low value will be reaches to the 1. Like that it will be modified. Okay. I don't know. Most of the students will be joined Telugu. Maybe Telugu. Then we will cover it with the Telugu batch only. I don't know exactly. We already have a one Telugu batch also. It's going on. They scheduled for English batch. That's why I'm speaking in English. Otherwise, I will tell you in Telugu also. Now you got it right.
Yes.
Yeah. Like it might be little bigger thing. We will tell you next classes with detailing. Now just here when we are transferring any power with respect to the two wires. The CAN has two wires. One wire will be CAN low and CAN high. The two wires transferring 5 volts of power. With the 5 volts, the deflection of the voltage, then the message will be going to the CAN network. The deflections happen the CAN low and CAN high wires. Then only the message will be passed down into the CAN network. Okay, is there any doubts for Madhavi? Do you have any doubts?
I have a doubt regarding అది జాబ్ ప్రొఫైల్ గురించి. అంటే ఇప్పటివరకు నేను బ్యాంకింగ్‌లో పనిచేశానండి. స్టిల్ 1 మంత్ బ్యాక్ వరకు.
Okay.
నాకు మ్యారేజ్ అవ్వడం వల్ల సో, నేను అది వదిలేసి రావాల్సొచ్చింది. ఇప్పుడు ఈ డొమైన్‌లోకి చేంజ్ అవుతే నాకు ఎలా ఉంటాయి?
Okay. Before మీరు ఏం చేశారు డిగ్రీ బీటెక్
బీటెక్ ట్రిపుల్ ఈ.
బీటెక్ then you will be comfortable, right? Serious.
ఓకే.
You will be more comfortable in this.
ఓకే.
Maybe
మాకు
BCom students, it might be little complicated. Triple E, EC, BSc, these candidate like will be very comfortable.
ఓకే. మేము ఫేక్ ఎక్స్‌పీరియన్స్ ఏమన్నా పెట్టాలా? అంటే ఫ్రెషర్‌గా మాకు ఆపర్చునిటీస్ ఎలా ఉంటాయి?
Fresher కొద్దిగా కష్టమే. ఓకే. బీటెక్ ఎప్పుడు పాస్ అయ్యారు?
13 పాస్ ఔట్.
ఓకే. 2013.
యెస్.
ఒకసారి మోహన్ సార్‌ని అడగండి. మోహన్ సార్ చెప్తారు. ఎలా ఏంటి అనేది. అంటే ప్రాపర్ ఎక్స్‌ప్లనేషన్ సార్ ఇస్తారు.
ఓకే.
అంటే మనము మరీ అంత ఎక్స్‌పీరియన్స్ అనేది ప్రొవైడ్ చేయలేము. అంత ఎక్కువ దూరం ఉంది కాబట్టి మేబీ హి విల్ గివ్ ఒక గైడింగ్ అనేది ఒకటి ఇస్తారు, ప్రొవైడ్ చేస్తారు. ఎలా అంటే ఒక 5 ఇయర్స్ మామూలుగా నాన్ టెక్నికల్ సైడ్ వర్క్ చేసి తర్వాత ఈ విధంగా నాకు మ్యారేజ్ అయింది. లైక్ ప్రాపర్ ఎక్స్‌ప్లనేషన్ ఇచ్చుకొని తర్వాత ఒక 3 ఇయర్స్ నుండి నేను వర్క్ చేస్తున్నాను అనే ఎక్స్‌ప్లనేషన్ మీకుంటే ఎక్స్‌ప్లనేషన్ ఇవ్వగలుగుతాం అని కన్విన్స్ చేయగలుగుతారంటే దెన్ ఇట్ మైట్ బి వెరీ ఈజీ. ఇక్కడ
ఓకే.
ఈజీగానే ఫిట్ అయిపోతారు.
అంటే 6 ఇయర్స్ బ్యాంకింగ్ ప్రొఫైల్‌లో ఉంది ఎక్స్‌పీరియన్స్ కాకపోతే.
హ్మ్.
నాకు అది గవర్నమెంట్ సెక్టార్ జాబ్. సో, పీఎఫ్ కూడా ఉంది.
ఓకే. ఒకసారి
అది ఏమన్నా ప్రాబ్లమ్ అవుతుందా?
ఫ్రాంక్‌గా చెప్పాలంటే నాకు వీటి గురించి తెలీదు అంతగా.
ఓహ్! ఓకే.
ఒకసారి మోహన్ సార్ ఉన్నారు కదా! మీకు లింక్ ప్రొవైడ్ చేశారు చూడండి.
ఓకే.
ఆ సార్‌ని కొద్దిగా కాంటాక్ట్ అవ్వండి. ఎక్స్‌ప్లెయిన్ చేస్తారు.
ఓకే. థాంక్ యూ.
యాహ్! ఓకే. యాహ్! ఆహ్, రేపు మీట్ అవుదాం. వి కెన్ మేక్ ఇట్ టుమారో. గుడ్ నైట్.